For this video, we're going to use the same exact chemical equation that we used in the last one, except the last one asked us how many moles, so this was our unknown, how many moles of sodium would we need to produce 4 moles of hydrogen gas? In that video, our answer ended up being 8 moles of sodium. But we're going to switch things up and throw you a bit of a curveball. We're starting off with 8 moles of sodium in this video. And the question is, if we have 8 moles of sodium to start with, how many grams of hydrogen gas would we end up with in this reaction? Just like any other problem that we've done with dimensional analysis or stoichiometry, we're going to start with what's given. And I'm going to write that in red. So we have 8 moles of sodium. And then we're going to look at our mole ratio, because if we have moles of sodium on top, we need moles of sodium in the bottom to cross cancel, to eliminate that. So looking at our equation, we're going to have 2 moles of sodium. And if we are converting to hydrogen gas, that's what we're going to end up finding out. We're going to have to go from moles of sodium to 1 mole of hydrogen gas, and those moles of sodium end up cross-canceling. Now in theory, if we were to stop here, you would see 8 divided by 2 would give us 4 moles of hydrogen gas. That's what we had in the last problem, in the last video that we did involving this chemical equation. But the question isn't asking us to find how many moles of H2, it's asking us to find how many grams. And anytime you have to deal with grams, you're going to look at that periodic table. So just like here, we have moles of sodium on the top, moles of sodium on the bottom. We're going to do the same thing. In the next fraction, I need moles of H2 on the bottom. That way we can cross cancel these. So the big question is, how many grams are in 1 mole of H2? Well, if you look at the periodic table, 1 mole of pure hydrogen, just H, is 1.01 grams. However, this is moles of H2. We're looking at a diatomic. This is just H by itself, but because we have a subscript of 2, technically we have 2 hydrogens. So the molar mass of H2 is going to end up multiplying by 2 to get 2.02 grams. This is our final unit. That's what we want in our answer. And I'll go ahead and I'll write our final answer in this brown color here. But I also would like to simplify without using a calculator. That way I can potentially make my life easier. And this is something that you're going to see more of as we do more stoichiometry problems. So I'm actually going to cross cancel and write our final answer in this nice blue color that you see right there. This little smiley face. So you'll see that'll be our final answer in that color. So notice you have 8 over 2. I know they're in different fractions, but one's in the top, one's on the bottom. You can cross cancel those to get 4 over 1. So that way, if you look, we have in all our denominators, we have all 1s. So you just end up multiplying those tops. You have your 4 times 2 times 1.01. That's the same as 8 times 1.01, which gives you 8.08 grams of H2. We know it's grams of H2 because that is our final unit of measurement. This is our final answer. So we started out with 8 moles of sodium, and the question was how many moles, if we have 8 moles of sodium, how many grams of hydrogen gas would we end up with? As long as you remember that we have 2 atoms of hydrogen gas in that one molecule, and you multiply that by 2, you should get 8.08 grams of H2.